Last time on Recreating Mathematics, we checked if base 12 was better than base 10. Our results were a little bit difficult to understand because base 10 seemed better at first, but then we used a different measurement and base 12 seemed undeniably better. But is there something else? In this video, we're going to decide once and for all which is the best base. I'm now using a crazy method of comparison using the number of digits in decimals from 1/2 to 1/25 to find the best base. So this is what we made last time, a table for all the decimals, and I'm going to remove the ones that have a very long decimal expansion, like 1/3 to 1/2 to 1/6. They're all pretty short. 1/6 has 4. And now 1/7 is pretty big, 6, which is 1 less than 7. That's the worst you can have. So I'm deleting 1/7. And now 1/11 and 1/12, they're all right. They're not very, very large. Now we have 1/13 and 1/14. I'll remove both of them. They're long 6-digit cycle. 1/17 is a very long one. Again, it's 16 digits of the period, which is 1 less than 17. It's the worst you can have. I think it's the same for 1/19. So off those two go. 1/21 is the same as 1/7, so it's still going. 1/23. Don't get me started on how long this monster is. But this is only in base 10. And this list is quite long. Now in base 12, 1/5, that's not that long compared to what we've been doing in base 10. It's 4 digits, which is 1 less than 5, so it's still the worst you can have. Deleting 1/7, 1/10, 1/13, not 1/13. That's alright, it's 2 digits. 1/14 is going in the bin, as is 1/15. Wow, they're getting slashed, the base 12. 1/17 is getting slashed. 1/19, 1/20, 1/21, all of them are long. Doesn't look very good for any of them. 1/23, I think it's a bit shorter than base 10. And 1/25 is a bit shorter as well, but still long. So I'll put these numbers here so we can do things with them. What things? Let's find out. Some things to notice. I could go on for ages about the amazingness of these decimals, but first, the divisors of 10, 2, and 5, and the powers of 2, like 2, 4, 8, 16, and the powers of 5, like 5 and 25, all of them have terminating and relatively short decimals. There is another aspect to this, but let's just keep it there for now. For base 12, the same is true. Its divisors 2 and 3, prime divisors I should say, and the powers, like 3 and 9 and 2, 4, 8, 16, those all are terminating and short. In fact, I should say most multiples of 2 and 5 for base 10, and also for base 12, 2 and 3 are there. Like for 2, we have 2, 4, 6, 8, 10, 12, and then 16, 18, 22, and 24, and 20. So we're only missing 14. In fact, there are no multiples of 7 in the base 10 or the base 12 ones. They're all gone. And also check 11 and 9 for base 10 and 11 and 13 for base 12. Those two border 10 and 12, but those two do not divide by 10 or 12, but they are still short. There's a reason for this, and let's move on to that. This will be essential for not only giving us the most divisors, but also giving us the least amount of decimal places because of these special 9 and 11s. Also, the multiple of 9, 18, and divisor of 9, 3 work. 11 times 2, 22, that also works. Let me prove the second bullet point now. So, if you have any base and you square it and subtract 1, according to the difference of squares, that would be the base minus 1 times the base plus 1. And you know that 0.9999 is equal to 1. So if you keep repeating those, you're going to get 0.99999 in the base. So there we go. That's proven. Okay, so let's check which base has the most prime factors for n minus 1, n, and n plus 1, n being the base. But keep it under base 16 or hexadecimal because after that, counting gets ridiculous. The grand finale 2. You'll understand soon. The best base is base 14 because it has 5 factors. from 13, 14, and 15. 2, 3, 5, 7, and 13, and the smaller the more frequently they appear. So these are small, and that's good. So base 14 is the perfect base. It doesn't make counting ridiculous, and it makes decimals easier. Well done, base 14. But it has 369 digits, and it doesn't beat the 320 in base 10. But it did base 15 for reasons I won't get into, and that beat it with 309 digits. 15 is more familiar than 14. It is a multiple of the numbers of fingers on a hand, and is good for similar reasons to base 14, so let's grow another hand and use base 15. Fun fact, the first number to beat 14 in the factors is 34, with 6 prime factors, but of course counting it's ridiculous. Thank you for watching, and this is the end. Don't forget to like, comment, share, and subscribe. Bye. Thank you.